Okay. Again, I'm testing this out. So this is a presentation that I've made. And I just want to explain what physics is all about. In short, not a comprehensive explanation, but just something for people to at least understand what physics is about. So first of all, I think I was on the last page, so let me do this and try again. So what is physics? So physics is the study of matter, of energy, and the relationship between matter and energy. So that is the basics of the definition. It is a lot more comprehensive than that, but just for those people that would like to at least understand the basics of the subject. So I've mentioned that it's a study of matter and energy and the relationship between matter and energy. So we need to look at what matter is and what energy is. So matter is basically solids, liquids, and gases. So those are the things that you see around you, solids, liquids, and gases. That's what constitutes matter. Okay? And here's an example for ice as a solid, water as a liquid, and water vapor as a gas. But we have other solids, other liquids, and also other gases. So what is energy then? If physics is the relationship between energy and matter, what is energy? So when we talk about energy, mostly we look at the types of energy, because you cannot pinpoint and say that is energy, but you can say that is energy changing from one form to another form. For example, in that picture of lightning, okay, you can see there is light, but there is also the sound from the lightning. So there is a change of energy into sound and into light from the interaction of the clouds and the charged particles in the clouds. And so what are the other types of energy? So we have kinetic energy, which is the energy of moving objects, gravitational potential energy, which is the energy possessed by an object by virtue of its height above the ground, and its gravity is always acting toward the center of the Earth or of a planet. And we have elastic potential energy, which is the energy of something which is stretched, an object which has been stretched. So if you squash a rubber ball, it also has elastic potential, is likely to go back to its original shape. Then we have heat energy and chemical energy, and obviously we have light energy, as exemplified by the lightning, the picture of the lightning. So what do we mean by the relationship between matter and energy? So all matter is energy. So all the solids, liquids, and gases, they have energy. But solids have less energy than liquids, and liquids have less energy than gases. So gases have the most amount of energy. So the energy in matter is due to the movement of its particles. Fast-moving particles have more thermal energy, which means that gases, or if you look at the example here of the boiling water, the water vapor, okay, that has more thermal energy than the water or the ice, okay. As much as the ice is cold, okay, but because the particles are always moving, there is some vibration taking place, there is a level of thermal energy in the ice which is much less than what we have in water vapor. So ice is a solid in this case, water the liquid, and water vapor is the gas. Okay, so let's go back to this slide. Fast moving particles of more thermal energy, we've gone past that. So why should you study physics, or why should you encourage your children to study physics? Well, first of all, physics is based on the scientific method of inquiry, which is basically the ability to investigate questions of phenomena which are taking place around us. So anything which is taking place, like falling rock, we are able to investigate why the rock is falling. So the first question I ask is, why is the rock falling downwards instead of upwards, for example? And then we can try to offer an explanation as to why that is happening. And so we employ the scientific method of inquiry, and that means asking a question, providing a hypothesis, and coming up with some variables that you're going to measure. Because in science, if you cannot measure it, okay, you cannot define it. Okay, you've got to be able to measure something in order to make sense of it, in order to come up with a conclusion. So we have variables, and there are three types of variables that we normally look at. So we have the dependent variable, the independent variable, and the independent is the one that we choose. So we choose a variable that we are going to change. So we can change the height, for example. We can change the height from which a stone is falling. Okay, so that's the independent variable. And then the dependent variable is what we're going to measure, because it depends on this independent variable. It depends on what we choose. So we choose the height, and maybe we're measuring the time it takes to fall. And so the one that we're measuring becomes dependent on the one that we've chosen. Then we also have the control variable, which are the things that we keep the same. So if we were investigating a falling rock, for example, we could say we're going to keep the rock the same, but we're going to change the height from which it's falling, and then we're going to measure the time that it's taking to fall. Or we can say we're going to keep the height the same, so that becomes our control variable, but we're going to change the size of the stone. So the size of the stone, because we are choosing it, becomes independent variable, and the dependent variable is the time that we are measuring. Okay, so what has physics ever done for you and me? Well, physics has improved human life. Life expectancy has tripled over the past 200 or 300 years. We used to live up to the age of maybe 20-something, 30-something, or even 40, but now we can live up to 90-something, even over 100 years. So we've almost tripled life expectancy, because now we understand some of the things that used to kill us as human beings. We used to be killed by the tiny microbes. Now we understand where they live, what they need, and how to get rid of them. And if we're ill, we can go to a hospital, and a lot of the diseases that are available now, we can take care of that. Okay, so it has improved human life in many ways. We are warmer, we feed better, we understand food, we can grow more food and stuff like that. And that's why we came up with the agricultural revolution, which solved the food problem. The food scarcity problem was solved by the agricultural revolution. I know that there are countries that are still lagging behind in terms of looking after their citizens, in terms of providing enough food for the population, but in general, the technology to make sure or to ensure food security are available. It's just a matter of planning, which is lacking with some of these guys. Okay. Then we have the Industrial Revolution, which has provided the machinery that we use for the agricultural revolution. The Industrial Revolution brought a lot more products and services to people. Obviously, the Industrial Revolution, and it's still, the Industrial Revolution is still feeding back to the Agricultural Revolution, because we are making more or better equipment for farming, because we need to grow more food. The population of the world is growing. And it's also brought about things like television, things like computers. All those have been brought up by the Industrial Revolution. And the Technological Revolution, obviously, where technology has become commoditized. It has become a commodity, and technology has been an economic driver for countries like Japan, for example, and every country on earth which is able to produce technological gadgets. Okay, it's able to grow its economy that way. Then I come to GNR, which basically is genetics, nanotechnology, and robotics. Now, these three are the next drivers of economic growth and development. So, any country which is investing in GNR is actually going to be providing the products and services that are going to be consumed in the next wave of economic growth and development. So countries which are investing in GNR are positioning themselves to be the manufacturers of future products and services. Then we have the internet. The internet is democratized wealth creation, which means anyone with access to a mobile device and an internet connection can basically start a business on a mobile phone. The amount of technological or computing power on a smartphone is a lot more than the technologies or the computing power which landed the first person to land on the moon. So we have a really powerful gadget which I think is underutilized. Then we have social media. Social media is, a lot of people misunderstand social media because of the word social, and we associate social with taking some time off work and relaxing. So I think the word social is really inappropriate at this stage. Social media is a platform, or these are the new platforms for commerce. Okay, the new platforms for buying and selling, the new platforms or the new marketplaces. Okay, this is the new marketplace because what it does is it provides people with the customers that can buy their products and services. And a lot of people are spending time talking to friends, which is great. But what companies are doing is they're using that information to place targeted advertisements, which are likely to make you interact with a certain product or service and maybe sign up for it and buy it. So this is what social media is doing. It's a place where you have the opportunity to create value, provide value, and get the attention of people. And once you have the attention of people, then you can monetize that attention. Whether it's companies asking you to post about their products and services on your social media platform because they know you have a large following, or it's just you selling your own products and services, or maybe you're drop shipping and you're selling products and services from elsewhere. Okay, so that's social media, and it's about value creation. And that was my last point, that creating value is what you should be focusing on. Okay, so that is physics, and you can see how with physics we end up talking even about the economy, because everything that is the economy today has its basis. If you look around you, look at the technology around you, look at the computer in front of you, look at that mobile device you're using to watch this, look at the printer there, look at the microphone, the refrigerator. All of these things have been manufactured using the principles of physics, using the knowledge that we've acquired from physics. Okay, so I think this is the last slide, and so I was talking about physics and what physics is, and just a recap: physics is the study of matter, which is solids, liquids, and gases, and energy, and there are types of energy like kinetic energy, potential energy, gravitational potential energy, heat energy, light energy, and these energies are changing from one form to another, and when they change from one form to another, work is done, and in order for them to change from one form to another, sometimes a force is applied. Okay, so then we have the relationship between the matter and the energy, and that's what physics is about. So guys, thank you for listening. I'm going to log off now. If there are any questions or comments, you can always put them in the comment section. So thank you again for listening, and I will see you in the next video.